on this Typhoon project. Here's one of those pictures you wonder, can we write the caption for this picture? Send the caption in to 1-800-GOOSE HUNT. Anyway, let's get down to shop. I'll mention the work. Part of our Typhoon project is that we're going to be building a built-up wing, in some ways similar to the Miss Ashley wing, but in some ways a little bit different. The first thing we're going to do is we're going to wipe all the lines off of this, because we're going to be moving the spacing on the ribs on the original Miss Ashley. The spacing was 2 inches, and we're going to make that 1 15/16. Now the reason for that is because we don't want to wind up with a wing that's bigger than the original Miss Ashley wingspan. We want to keep the span, and we're going to do a slight juggling of the rib spacing so that we wind up with a plane that this total span is exactly the same as the Miss Ashley, which we felt was one of our best wings. I don't want to change the total length of the span. Now just so I kind of get my point across here, a lower aspect wing, like a Strega, is a lower, the aspect ratio meaning how thick the wing is, the span relative to the chord, the mean average chord, which would be the average of the tip and the root. A wing like, let's use a Nobler for an example. A Nobler is a relatively low aspect wing. Now if I were to take this wing and just add 2 inches onto each end of it, it would become a higher aspect ratio wing. The problem with real high aspect ratio wings is in level flight they tend to be unstable. The thing you gain with a low aspect wing, you gain stability. The trade-off is you need to at some point in time balance the plane further and further back to get an equal corner. Now, it's all a compromise. A 92 Cardinal is a little bit higher aspect ratio wing, which means it tends to, the higher aspect wings tend to carry a little more weight. They tend to be a lot less groovy and a lot more, they can turn more violently. But the compromise that we liked was the compromise we reached with the Miss Ashley wing, and that's why I'm having these ribs set up on a laser to be laser cut in the future. This was a good compromise. I don't want the span to get any longer. I want the span to stay the same. So what I'm doing, and because I'm going to use 3-inch tips instead of 2-inch tips, I'm moving each rib in closer by about a 1/16 of an inch, and of course I'll measure that all off ahead of time and then mark the lines on our granite plate. Okay, if you're a new subscriber and haven't seen how we made the Miss Ashley wing, this is a piece of granite tombstone or countertop, as the case may be. It's a rough edge on one side, we don't really care, but it is completely flat, and on the last tape we always double check it. Although I can't imagine if this goes out in bows or bananas or whatever, I don't know. I'd be afraid the world was losing its shape. But anyway, I need to wipe these lines off and then reorient them in to the place. I'll do all that off camera because it's just a redundant mathematic thing, and all of that will appear on the plans that'll be available when the plane is finished. And just one more final thought here about high aspect wings. These were the wings that were designed by Big Jim Greenaway. And I thought these were just exceptional aeroplanes. Problem was, at the time, we really didn't have the flying skill, I think, available to push these to the limit. But the white one here had gotten fourth at a team trial. The black one was a very short-lived plane, but both were excellent flyers. But again, these planes are a higher aspect than long and thin wings. They tend to have some really good features, but everything on our plane is a compromise we want to arrive at. Our 85 plane was another one of the real high aspect ratio planes. Again, if it were just a question of how high an aspect ratio you can make it, I think Dennis Adamson had the highest aspect at about 7:1. These were 6.3, and I've kind of settled in on the ratio that Miss Ashley is. I've kind of just felt that was the best of all the compromises, and that's why we're using that number of the ratio relative to the airfoil thickness, relative to the wing displacement, and by having a combination of all of those things, and they're in a good package. And I think that wing can be built as straight and light as just about any other wing. A higher aspect wing, if we were to make that add 2 inches of span on each tip, what might happen is we'd wind up with a plane that had a little more instability, and I kind of felt that one was the best. And we're going to change two things on this. We're going to change the tip shape and the flap, because a Typhoon has a lot of taper in the flap, and I want to keep it as scale as I can possibly do without trading away any of the good flying characteristics. Is just using isopropyl alkyl. And by the way, if you don't know where to get any place that makes tombstones or granite countertops, what I found is these scrap ends, they usually throw away, and they have to pretty much pay to have them taken away. Mike's got 2 or 3 of these now. I think he's got one that's a little small. But what we found out is they're more than glad to get rid of these scraps. And what you need is a piece the size of the wing you're going to make. This edge doesn't really have to be perfect, but we get a nice, you'll always have one smooth surface, one edge, and boy is it handy. At the end of working on it, you take it and put it outside. You don't even have to put it inside. This combined with the 3/8 the rods, you almost can't make a crooked wing. This is really my favorite way of making a wing. Just leave the 2 center, every time we build a wing on this, I leave the 2 center ones there, because this goes right under the fuselage sides. Now what I'm going to do, I'm going to go get that fuselage mold and measure exactly where these sides rest, because if they're a little bit further apart or a little closer, I want to adjust these to the thickness of the fuselage. I'd like that rib to be right under the fillet of the fuselage. So that's the first calculation I have to make, is to get that. You wouldn't want it in the middle, you wouldn't want it further out. You're going to have a problem. Right under the fuselage, so the side is resting right on the rib. Turns out our fuselage is just under 3 inches, and this was 2.5. So we're going to add about 1/4 to each one of these, and of course all of this will be on the plans. But for right now, I'd like to get this dimension right. This is my starting point, is just under 3 inches. So I'll erase these lines also. Nice about having this, whatever this is. We don't even know if this is granite or marble. I'm assuming it's granite. But it's lucky that these companies really, what could you make with this? You can't, what you can make is a great wing jig. And but it will last a lifetime, and it's free. And those are a lot of good characteristics in one part. Oh nice, you can get these Sharpie markers, they write on, it stays relatively, on the part. And where's my little dot here? It's going to be kind of a wide fuselage, so I wanted to make that adjustment to the center ribs just under 3 inches. Step is I want to just temporarily lay out a piece of my green tape, because I want to put very accurate lines. I don't want to use a Sharpie marker. I want to get these lines very accurate. To get an idea of what I've done, I've just marked this for my own benefit. This is the dimension I want. It's 1 15/16. So what I'm really trying to do here, and this is going to be a temporary thing, And I'm going to take the tape up once I have the lines on. But I want to get them 1 15/16. The easiest way I know of to do this is a really handy tool John Pothier gave me. And this will set my rib spacing. Now, see what I did? This is interesting. You'll love this. I'm working off the wrong side of the tape. I'm looking and I say, what do I build in an I-beam wing? Oh no! See, that's what having bad eyes will do for you. It's 1 inch and 15/16. And if you think those are the kind of mistakes you can't make, this is why I can't see anything. No, I didn't plan it that way. This is why I like to lay everything out ahead of time. Life is hard enough without figuring out ways to make it harder. Okay, now I have. That's 1 inch and 15. I know you're all laughing. Let's get it straight once and for all, Wendy. Just make an X out of that. See, now I want to work with. This would be the center of the ribs. And then from these lines, see, now that I have those dots, I know I just dropped the triangle. Well, I'm not having a good day. It's a little hangover from Christmas. But once I have this, now I know I can set these temporary lines on here. Because now, see, if I want to change the lines, I don't want to go scribing all these lines on with a Sharpie marker yet. I want to do all my calculations and measurements because I have to allow for those rounded wingtips and the wider fuselage. So in effect, the ribs have to come closer together. Okay, now I have the proper layout for all of the rib stations. Now I need to go back with the Sharpie and lay in nice solid lines. As soon as I'm done with the lines, I'll pull off the tape and then scribe the back. See, now the back of this is a perfect edge to work off. It's perfectly flat, it's smooth, and it's a 90-degree cut, so it really works well working off of this back edge for the whole wing. For making a permanent wing jig, you were going to only build, let's say, Nobler wings or whatever. Well, one of the things you do is you could use these. They make markers like this that are absolutely permanent. They're made for laundry. This is not one of them, though. But this gives you the ability to erase it. Well, let's say if you want to go back to making the next wing was going to be a little bit different rib spacing. But when we're done, we'll have all the spacings laid out. And this is the easiest way to get a little reference for your rib settings. You try to build off paper plans and they're wrinkling, and if you can transpose it down into a piece of granite. Once I have these lines scribed on, I can get rid of the tape. I don't need the tape anymore. And then I can use the line itself. And I'm ready to lay up the... Now, if I didn't have these little end blocks made out of aluminum, you certainly could make them out of a piece of plywood, light ply. They don't need to be made out of aluminum. The only thing we had somebody I don't remember who donated them. But certainly, the objective is to just hold the rods in alignment. And I'm assuming you could probably even use balsa wood with plywood on both edges. Okay, all lines are on. We've checked our total span. And we're exactly where we want to be. And we'll be allowing for 3-inch tips here. Yeah, I have engraved right on. Please return to Wendy. You know what? I'm going to make 20 phone calls to get these back. Beside the point, I still need my tool for making sure everything's aligned. Now, I usually just tack these down with a drop of CA. And I'm going to maintain that edge. I'm going to maintain the black line is going to be where the rib actually... Oh, you sloppy thing. Down there. I like to build a nice little bead of glue on this outside one. which actually will become the inner panel, is I want this one nice and solid. I leave the other one loose until I have all the ribs laid into position. These are rods I got from Joe out of Musco, and they're stainless steel. The way you tell if they're nice and level is you roll them on a table, and they shouldn't be going like a bird starting to fly. But you can see what's happened. The last person, won't mention any names, that used these left little globbers of glue on them. So what we need to do before we can go any further, get rid of all the globs of glue, which is pretty normal. Probably that's the only one. And then I want to go get some, I like to use part-all wax and wax the rods. This way, if some glue does get on them, I always check if they're relatively layered or okay. Because we're going to have a jig set up that we can, even if I have to make one. This one's nice and clean. That must be the one I used. Next thing I want to get, it's always a good idea, any kind of car wax, any kind of wax. Wax on it, because if that rod glues to a rib and when you go to twist it to take it out, it crunches then you can't wax it. You got to wax it now, not later. I like to use the same wax that I use for mold releasing, part-all. I love to break my fingernails opening this up. Boy, these are lousy cases. Trick number one, don't break your fingernails on these cases. Anyway, I always leave the rag in there that has plenty of the wax on it. Now I don't know why, but every time I use this wax, I'm more convinced more than ever that there's some ingredient in this wax that makes the bird crazy, because he'll start peeping and squeaking and giving us his mating call and everything. Actually, you don't even have to polish this off well, because this is polished stainless steel. Second choice is you can go down to your local Home Depot, and they usually have rods like this for about $3 a piece that aren't stainless. But if you keep them waxed, one for all. I was even going to try to get Midgley to Teflon coat a set of these rods. Then I found that it's $300, and I said, forget it. Buy me another Sato instead. Okay. Once these rods are polished, and believe it or not, it's little steps like this that if you forget to do them, somewhere down the road, you glue one rib under some sheet. It's always under the sheeting too, and it'll make you crazy trying to get the rod out. And the worst thing I've ever seen is I had somebody over the shop who decided while I was out at the post office they were going to remove the rods, and just went, well, you can't do that. You got to twist them, make sure they're, and if they look like they're glued to something, Anyway, a couple of coats of this wax, really good tip. It's a tip you want to use too. See, a lot of these tips, most of them, they're just common sense. They're not real high-tech things. Most of the things to make a nice aeroplane are more common sense than high-tech. Best, the part-all or Simonize. Once you have even one coat on that, when CA does work its way down in there, you even can get it after the wing is built and get in there with a blade and knock it off. If you don't wax them, a lot of times that CA will just grab it and you wind up making you crazy. Before I go any further, I want to get a little piece of tape or something on these rods, just so while I'm sliding the ribs on, I don't wind up. Again, this is one of the little things that just makes it go easier, because once you have this going, it goes real quick. The preparation, like anything else, the preparation is a big part of it. Now they can't slide back out. And the rods are plenty long. They're an inch or two oversized on both sides. Now, even though this is entering the realm of, like diminishing returns here, I want to weigh the two sets of ribs. The lighter of the two will become the inner set, of course. And there's about not even a grain of difference between them. Anyway, this will be real handy. Once these are programmed into the laser, all this cutting and sanding will be done. Now, one of the things that's real easy to do by mistake is get the ribs slid on, and then notice that one is not the one it should be, and that's the reason I have them all numbered. I've already gotten to the point I've laid out ribs and then see number 13 and 12 were backwards, or that I was building a wing and a gear block slot was on the top and one ribbon on the bottom of the other. So at this point, it's really a good idea to just one rib at a time, slide it on the rods, check the number, check the orientation that you're not going 13, 12, 15. That's why I have them all marked. Get some rough idea. If you'd like to, you could use the lighter ones on the inner panel. Save about a grain of tip weight that way, which will probably, it can't hurt anything. If you're working alone and you're sliding the ribs on, of course, it's a good idea. Have a piece of tape on both sides so now the rods can't slide either way. If you have a helper, of course, this is really not he can just hold them in place. But this is, I try to invent everything or work on everything as if I have to be here alone to do it. Now I need to go out to the other end and one by one slide the ribs on and get them in the rough position that they're supposed to be in. And this is where it can get a little awkward if the rib holes are not right. Now this last one I'll leave at a place because I have the tape there. I'll take them one by one and just slide them on and get them in the rough position that they should be in. Now once I get to this point, I want to walk down the ribs and make sure, again, because once you glue a spar or something in, boy, is it a job getting it out. My little check, count the numbers. See? That's number 4. And so once I know I have one side on, and of course then I can just use the other side. And while I'm holding this up, a good thing is this will ultimately be the center support. I use this piece just to hold this up as I'm sliding the ribs on one right after another. And then I want to line them up, and this is just an eyeball thing right now, kind of line them each one up very close to where the line is. And then I can sight down and see if I've got any that look a little. What I do now is just put the rest of the ribs on the other side. I'm satisfied that this is exactly as it should be. And by the way, if any of the ribs, the hold is getting kind of bindy on the rod, it's a good idea to take that copper tube and just push it through one more time, because you don't want to have any friction on this. When that rod comes out, it's got the friction of all 30 of the ribs at once, and you don't want to hopefully have no friction at all on that rod.
And I started, so thank you, my dear.
This little gizmo's been holding it up as I slide the ribs on. The next step I want to do is replace the little block that we have. Again, these jobs are real easy to do when you have 2 people. You have to be a little creative if you're going to do it when you're in the shop alone. And because they're a tight fit, I want to slide them on real slow. I want to get this right in position and then just CA it. Now, one thing nice, when you pull a CA off of the granite, it doesn't take chunks, at least so far, it doesn't take chunks of granite with it. Now, there's one little problem already that I can see. See how much of this rod is sticking out on this side? What I want to do is take the tape off the other side and slide these rods in, because every time I walk past the table, you can imagine some of the people in this shop are even as clumsy as I am. And I want to line this right up with the trailing edge. So once I get this glued in place, then I can just slide the rods, twist them slowly, and get them moved up. Just using the center block to make sure I have the alignment right even with the corner. That's one of my alignments. Now needless to say, I have to go take the tape off the other side on the inside so I can slide these rods through. It's little details like this that just make it, if you leave one detail out, it really gets difficult. Okay, now I want to make sure the rods are loose enough that I'm just twisting them a little bit and moving them just a little bit at a time. Needless to say, I'll have to reposition all the ribs. Now there's resistance because we're twisting against all of that balsa wood at once. Rods, even with my big gut hanging in there, that'll be fine. This is solid, it's aligned. Now I can very carefully get each rib slid into position. I know one time already, more than one time, I've already glued the rib right to the plate. I ought to think about not doing it this time. We'll find out. Well, what I'm doing, I'm looking straight down at each rib station. This is the nice part about the jig method. The rod method allows you to position each rib, and it's just enough resistance on those waxed rods. You can line up each one, and I'll check it to make sure they're all at 90 degrees, make sure one isn't laying down or sideways. But I can check this 4 or 5 times before I go on to the next step. Now my center support, what I did is I made sure that I'm at the same height, that it slides under here, and it's a nice tight fit, and that it's a nice tight fit. It just keeps the rods from bowing down when there's pressure on. Now, I can put a drop of CA on here if I want, a piece of tape, it really doesn't matter. Anything just to hold that, that's a temporary piece, that's not going to be there. Oh, I got it backwards. The skinny part goes in the back. And just let me see how easy this is. So, see, the rods do have a little bit of bow when you get them down this long. This is why you want to have a set. If you look on the 89 cardinal plans, you'll see there's a lot of tricks on making the center support on there. Now, of course, the final check is always that we're the same height off the table. The rods are the same height out there, over here. So we have one parallel set. Now with all the ribs in alignment, notice there's no glue yet on anything. Everything can still be moved around, but it still stays in position relatively on its own because of the tight fit around the rods. Now I try to sight to see if any of these ribs look a little higher or lower than their counterparts. My number check before I go any further, just to make sure I'm not not in big trouble. Now, if this is not right when I do my little check, so I can shim that with a piece of paper even. But I want to make sure these rods remain parallel and straight relative to this block of whatever we're going to call this, granite, I guess. Next thing I want to do, I want to make up a little go-no-go gauge for under those rods. Just an ordinary piece of scrap plywood. Plywood is good, light ply is okay. And I know this gauge, because I measured it off the block, I actually could have made this up ahead of time. But what I'll do is I'll cut this with the line on, and then I'll just touch sand it so it just fits under each rib station, and I can use this constantly to check that I'm not putting pressure or putting a twist in the rod. Now, of course, the gauge is oversized. You can see it won't slide under the rod conveniently. So what I want to do, I want to take the unfinished edge. Okay, so see what I've discovered here is I have a piece of wood that doesn't have a 90-degree cut in it. Anyway, that's the height we want right here. So I can pretty much, from this point, I can make a gauge. Then here's what happened. I picked up a piece of wood that didn't have a 90. See, it's not 90 degrees. So in essence, what happens? One side fits under, the other side doesn't. So let's see where it fits. right about there. And we can salvage this. Again, a lot of ways to do this, but if you have a little gauge, the easiest thing to do is just work off the gauge. Make sure that edge is 90, and this edge I'm sure is not going to be 90. See how much it's off? Good catch, Wendy. So I can just take this. This is the kind of stuff you gotta, and I can just flock sand that off. It's these little things that make the difference between having a wing that's perfect and a wing that's, well, maybe not even okay. Now I want it to be that when I press this under there, it stays. Still a little tight. That side's loose. So I know this side, I'm going to have to take the line off is what I'm going to have to do. Get used to taking the line off or leaving the line on to get a fit. Right there is where I want it to be. The other side is a little bit too soft now, but whoop, right there is where it fits. I broke down and made a permanent part of this gauge. I put a little T on the bottom so I could do this. I could rest it under a rib, and I could kind of feel, yeah, there's no clearance there. No clearance. I want to have just that it sticks with its own fit, and I want to have on at every rib station down the front and every rib station down the back. So having this little gauge for the duration of making a wing is really going to be an asset. Even though I had to make 4 of them before it came out right. It's no sin to make a bad one, just make another one. It's really invaluable because in the center is where it tends to sag. Now what I've done is, you can see I've shimmed this up until it's a nice tight fit. Whoop, front and back. I have, now if I were to take out one of my 64th plywood shims, paper is okay. IBM cards are IBM. Who has IBM cards anymore? Now see how? It's a go, no-go gauge. So I'm within a 64th of an inch here. If I put the shim back, and you know, if you really want to be cute, you could sand the shim. I think if you're within a 64th of an inch and jigging up the rods, though, you're in real good shape. Once that 64th is in there, now I've got my clearance back. Now we know, after all this fidgeting around, that the rod height to the table at every station is equal. And this is the part of it, it takes a lot of time, but once you get it right, it's pretty much going to stay there for the duration of making the wing. So this is the one part it really pays to take some time, get it right. Okay, with this, there's not a drop of glue anywhere in here. Now what do I want to do? I want to make up the trailing edge sheeting, and it has to be a joint in the center of that, or it has to be a joint somewhere. I'll choose to put it in the middle, a V joint. And I want to lay out and make sure I have a perfectly straight trailing edge on both sides, but I just want to tack the bottom piece in while I get the whole wing checked. See, every step of the way I want to check the wing that we're not putting a bow or a bend in it. Before I make up that trailing edge piece, well, 2 pieces, I want to select out not only the lightest pieces, because I have a lot that are really light, but they're twisted. There's some of them that are good, they're a little on the heavy side, but number one, for instance, let's just look at one thing. I don't think we want to use, I don't care if this wood was as light as air. That's not a trailing edge piece. What I want to wind up with, and I hope I can find, this one's not bad, but I want to have, look at this one, is only 9 grains, but when you look down it, you're going to make a trailing edge piece out of that? So what I'm trying to say is, you don't not only want the lightest pieces you have, but also you want to have the straightest. Now, I stripped off 2 pieces, the two straightest pieces I could find, and I want to show you what I think is a good little way of making up the trailing edge. And one piece is a little bit thicker here. I didn't get 2 pieces out of the same piece. Okay, so what I need to do is, before I do anything, is even these up. Because once I glue these, I thought I was going to get two out of one piece. Not so bunky. I want to weigh both. Yeah, they're both thick. Now once I get the pieces stripped off, then I want to make a butt joint, but on about a 45-degree angle. What I do is lay out the ruler. This is my straight ruler. And I want to make a relative butt joint, but I want to overlap it. It's not important how much we overlap it by right now, as long as the pieces are the same size. Now, because I'm working alone, I'll tape this to the ruler at several spots, and this will hold it in position. See, with that, the rib taped in place. Now what I'm going to come to is over the overlapping joints and cut both at the same time, and that gives me a perfect butt joint. Now by cutting both at once, I ensure that the butt joint will be relatively equal and straight, and it'll kind of be invisible once this is actually joined. And when we join it, we'll put a piece of Teflon sheet underneath. Now you can see what happened is I have a relatively straight joint. A nice little splice piece here. What I'm going to do is dress it off on the edges. Make sure that that tape is holding this. Now I'm on a sheet of Teflon. What the Teflon sheet does, it just lets the CA lay out flat. You can dress that right off in a matter of a second or so. Now I also want to undercut all of these angles to try to minimize the stress riser right there. Not that that's going to be critical. Now these pieces are oversized, so the next thing is I want to get the joints to lay right in alignment with the center of the fuselage and trim the edges. Now the two reinforcements, both of the trailing edges have a perfectly straight edge. Cut this trailing edge to length and then put a little dot on where each rib station is, because now I want to take the triangle and put a 90-degree line on here to just help keep the ribs in alignment. It's just for my own reference. Now, again, this is just for my reference to get these little lines on here. I just think it'll help give me a little bit of an edge lining up the ribs, keeping them in alignment while I have everything tacked in position, so I can always move it a little bit, shift it, whatever I have to do to keep everything nice and straight. And this pretty much relates to every rib station. And it's just a little guide, a little help for me to get this first piece pinned in here. Now I'm using these surgery pins that I got from John Pothier years ago. One of these days I'm going to have to buy some more. This is just to hold everything in position while I take a look at it. Make sure I'm not building any twists in before I start hitting this with CA. And once I have all the ribs pinned in place, now I just want to put just a few drops of CA on each one just to hold them in place. I'll still be able to move them around if I have to. I've been lining each one up as I go, and this is just tacking them in position. The next step is I laid the top piece right over. Make sure it's 90 degrees to the trailing edge, and just put a tack on the front, top and bottom of each rib. And that's about all I'm going to get done tonight. We'll come back to work on this tomorrow, but we're actually framed out here, ready to start putting in the spars. Tomorrow the wing will actually start to come to life. Now in today's mail, a lot of cool stuff here. I want to go through this. One of the things my friend Walter Umland is back in the model airplane building business. He custom builds for people. He sent in a couple of pictures of the recent projects he's worked on. If you're interested, his number is 252-637-5704. I'm going to go through some of the pictures that he sent in here. These are pictures of planes he's built for other people. Hey Walter, he used to live up by us. He lives down in North Carolina now. Again, there's always people that seem to need help, or either part of models, or a whole model built. And as far as I know from the past, the pictures Walter has sent me, he also does boat models, RC boat models. So maybe a good lead, a good thing for somebody that's interested, that needs some help with the building. You can see he's done quite a wide range of model building too. And you can see he does a wide variety of modeling. Right now, today, in fact, I'm sending him a Cardinal kit that he's going to be building up for a customer. So we're looking forward to seeing some pictures of that. And you can see, even if you're into a big high-end RC project, Walter will be glad to talk to you about it. Anyway, Walter Umland, Custom Modeler Supreme. Keep in touch with us. Let's see how that Cardinal kit's coming out, Walter. Now I got the biggest set of plans I've ever seen in my life here. This thing took up the whole shop. This is from Ken Clapson. Ken has taken a Cardinal kit, making swept forward wings, turning it into a pond racer. I see he's got the latest technology with the tail here, with the Miss Ashley type of tail. Cardinal wing, right out of the kit in fact. Swept forward wings. He's thinking about making the outboard part of the wings removable. Well, Ken, I wish I could have a great answer for you, but I don't. This looks like, just get an idea of how big these plans are. I'm trying to look at some of the little details. They go from one end of my shop. The real pond racer, the plans aren't this big. Anyway, if anybody knows the pond racer well, they know this is one slick looking. Boy, what a project this would be to mold up some booms here. And of course we affectionately call Ken Shady for his great artwork in the past. Anyway, we want to see some pictures of this as it evolves. I'll hang on to the plan, see if I can come up with some suggestions for removable wings. Just the Cardinal wing, huh? Well, I think this is going to be an awesome model. Every time I look at some new projects, see, when you break out of the mold and you're ready to do something really different, to me there's just a level of excitement in doing new stuff. See, he's got the wing, the two ribs, but he's got them swept forward instead of with a straight trailing edge. Anyway, Ken, we want to see, most of all, it's going to have two Satos in it. He's already got the motors and he's already running them. A very, very cool project. And if you love Reno air racers the way I do, warbirds, this will get your blood boiling. I want to put the spars in. I need 6 of them. You see, I go through a whole bundle of 50 or 100, and this is what I have. And I'm just going to be building stress into the wing. So what I decide to do, and I usually always do this, is strip my own. Set up my balsa stripper. By stripping my own, I can get the prime ones out. I usually don't get a whole lot of prime ones when you buy a bundle of these. This is what you really don't want to have because it just builds stress into the wing. Really don't know why, but you go through 100 of these, and this is one of about 6 bundles I have in the shop, and I haven't found one that's even worth using. Again, one of the problems is if you try to use these and then force it into position, you wind up building stress in the wing, and then when you take the rods out, the wing moves. So it's a little extra effort, but I think it pays to try to find the straightest piece of quarter, this in fact is quarter square, find the best piece of 1/4 inch wood and set the stripper and strip it down yourself. Even though it's a little bit extra work, you're not building in all that stress. What the stripper is, a lot of times you have to cut the 2 end pieces off and throw them away just to relieve the stress in the wood. Let's see if this is any better than what we have. A little bit extra work, but worth it. This is where I like having that nice tight fit on the ribs, that each one I can gently press it down. One by one I can line them up. I need to make very slight adjustments here so they're at 90 degrees as I go along. And then I'll make a little jig and check each rib that I haven't gotten them off 90 degrees. Put one tiny drop of CA on each piece. I just want this tacked in position just enough to hold it, but now it's not so tight that I can't shift this because I'm looking down at the ribs to see that they're all straight and they're all 90 degrees. And if I need to break one, I don't want to break a whole glue joint, I just want to break just that little seam. I always try to make up at least one long sanding block, because what I want to do with this block now is just pick up high spots. I don't have to even put any pressure on them. Those parts are just tack glued in place. But if there's a high spot, I want to pick it up. Otherwise, what happens when the leading edge sheeting comes together with the cap strip, or they're off this way, or they come to a point, and then right where you need the strength, you have it to finish. So by doing this, I can just get any little high spots that are sticking up. Now the next part of it's a little more difficult, is I'm going to put the bottom spar in, but I'm going to just, because I can't really get in at it the way I want to. You would think, oh, it's easier to put the bottom one in first. Maybe, but I've found it's easier to get the top one on. Maybe because I'm not left-handed or something. I don't know. Okay, that should be nice. Now the next thing is to fit in that bottom spar. And a lot of times, if you have a helper, you can get the helper to just kind of hold it and each one go down. Now, because I'm working alone, I'm going to try to get this in by myself. I like to get the top spar in again. It's my own personal thing, because then it holds this in position and it just makes it easier for me to work from the top to the bottom. But I'm assuming, there would be more than one answer to that that situation. Working alone, what am I, chicken liver? Tastes like chicken. I'll help you. Yeah, I really wish I could train them to do work. Always easier if you pre-cut the length, zone a saw the end off. Again, while I'm snapping this in, and this is why I spent all that extra time getting the fit to those little square cutouts so accurate, because I want to see it staying in place by itself. Now if I had a helper here, if I had a rich man, I can just press this in till it's even. And again, the same thing, I just want to tack it in position. I want to take each one and just put a little bit of pressure on it. I just want one tack on each one. I don't want a real permanent glue joint yet. Getting the fits right is the all-important thing here, so that these parts lock in position without the glue. Of course, the trick is not to get any glue on that rod, if possible. You know inevitably this rib gets glued to the aluminum and you have to razor it off, but I try real carefully not to get any on the impending rod, so when I pull it out it doesn't destroy the wing. Okay, we have one side done. Now I'm going to get under here with the sanding block and try to dress off any high spots. Again, it's just the reverse of what I've done on the top. That big sanding block is the best way I know of to do that. And a lot of times there's no high spots at all, but if there is, you want to get rid of them right now. A lot of times you can just work your hand under here, but if there's no high spot, and it looks like this is going to be pretty good, just move down one rib at a time, try to pick up if there is a high spot. You can sight right down here, and I like to sight down, see if I pick up any high spots on this, and if everything looks okay, top and bottom, I'll just work on the other side, do the same thing with the two spars. I'll do that off camera, and we'll come back and do the leading edge. The two parts, but I try to be real careful to get a nice joint there. Now, one of the things with the straight rule that I like to do, there's always a chance you'll pick up a high spot or a rib that's just a little bit out of alignment. I like to check this at various parts to see if I have a bow or belly anywhere in here. Okay, now see, here is a spot right here. There's a spot right here that's a little high. I didn't plan it that way. See, there's always a chance that you just get one. Better. But it's always good to correct them now. Just in the nick of time. All the hard work's done. Guess who shows up for lunch? What are we having for lunch today? Anyway, when we do the leading edge, and now that I have a helper, actually, the reason I'm holding the ruler is I don't want to make a snake out of the leading edge. So while Mike is holding that ruler in there, I'm just going to tack glue these in place, using a ruler to hold them in. We want this accurate, Mr. Kajeski. Late for lunch. I'll be here early, but I don't show up on time, Kajeski.
I just got off the Pennsylvania Turnpike.
He just got off the boat from Italy, I think. I got the leading edge in nice and straight. It was nice that Mike was here for lunch. Actually, he just came for a free lunch, as he always does. He's back at work. What I want to do, I always leave a couple of toothpicks here to remind me to get these toothpicks in. This is why I centerline all the ribs. I want the toothpicks sticking out the front, because after the wing is in silver and it's sanded, I want to be able to just take off some of that finish and find my center line. It's the one thing about a built-up wing. It can be difficult if it's not done right. It can be difficult to find that center line, because if you can sand one edge more than the other, you'll get it uneven in the front. Unless you can see a band of wood down the center, even that I like to leave as a second choice. First choice is to get the toothpicks in on center, and every wing I've done that on, the alignment on it has been real good. See, what I always do is drill a hole just a little bit oversized, and then get this lined up exactly on the center line, and just get a drop of CA on it. I'm letting this kick right now. I can hold it right in place while it kicks. And if it isn't right on center, then I can just break it and move it back. But even though this gets buried in paint, eventually I can always sand back down through and find that center line. That is a permanent, much better than taking and putting an ink line or something like that on there.
My life, an adventure.
Now, of course, the next step is going to be I'm going to trim this off with a Zona saw. I don't need the extra wood, but I do need that I can get in there and find that center line anytime I have to. That's a great trick no matter what actual design you're building, if you're making a built-up wing. You can sight down this way just to see that they're parallel. And now they're ready to trim off. I want to take a sanding block and dress this off because I don't want that to be sticking out. I don't need this piece in here either. All I need is that little piece, that little indentation sticking out the front. I want to be careful. I try not to break the ribs. Notice I use the word try. Anyway, now that's ready to just dress this off. Now before I lock this wing together, remember what's happened, these joints, all these joints are just tacked with a relatively small amount of glue. Before I lock this wing together, what I want to do is I want to check the center line down the whole trailing edge, the center line down the whole leading edge. And I used to have, again, I apologize, I used to have this really nice tool for doing this. Well, we know who's got it. We left them a phone call message, and if we don't have it in a day or so, they're going to get a visit from the mafia. Anyway, what I wanted to do is I know that the height off center, and what I've done is I've taken my black letter ruler, and what I want to do is I'm going to check this now at various stations. I know exactly where the height for this should be. So in other words, when I come down and drop this onto my, see how I'm lined up right with the center line? Let me get this straight. I'm trying to do this with one hand behind my back here. But I want to go to every rib station. I want to see the center line. And of course in the front, I want to see the center, for right now, the center of that. Or, as a double check, I can go right inside of each rib. I want to see right in the middle of each rib that I'm on center. Now what will happen is, from time to time, if you see you're out a little bit, before I lock in the trailing edge and put any of the sheeting on, I want to make sure this is, and again, this is probably one of the little parts. Now, I still could move this around, or I could break these kind of temporary joints. And this is time consuming. This just takes that little bit of extra time that it always seems to take, the jobs that you just hate to do. Now it looks like we are very lucky. But, for instance, if this had a bow or a twist, right now I could shim it in the middle. I can shift things around, or I can, in the worst of all works, break some glue joints, shim it up. I'm working off the rib, every rib center line I want to be right before I lock this into position. And of course, two of the most important ones are the ones that involve the center line here. We really don't want to have these off even by a little bit, because these are the ones we're going to reference our center lines off. I want that to be really right on the money. So far we've lucked out. Now before I cap this, I want to see if there's any hard spots. Actually there is, right here. When I say a hard spot, it's when I press a a flat block against it, it'll pick up on one spot and act like a little bit of a pivot point. Now, it's important that it's true in both dimensions, and if it isn't, so what I'm going to do, I'm looking for this is certainly not the lightest piece, but it's the best C grain that I can find. I'm going to cap the trailing edge off with 1/8 inch, and I'll strip this piece off. In the past, we've used thicker trailing edges, but what I'm going to do is I'm going to be making the flaps just a little bit bigger on this plane too, anticipating that with a 90, it may come out a little bit heavier. And just so I can follow through here too, the hinges, these hinge lines, because they'll be removable, they will always be taped. There'll never be a time when these hinge lines are not taped, so that doesn't become a factor. Just to see, the number one requirement here is that these be nice, straight, C-grain pieces. Certainly don't want to try to use up something that's going to turn into a pretzel. Yeah, because I don't have Mike here anymore. What I'm trying to do is I tape this into position so that I can go by and just tack it in spots before I actually run a glue seam. Again, what I'm trying to do is not build any stress in. What happens if you start gluing here and you keep forcing it down? Sometimes you put a little bit of a twist in it. If you tack it, then check that it's straight. Now you take the green tape off. Now, one of the things a lot of people have told me that they found real beneficial, Keith Ferguson was the biggest one, and he's a good builder, by the way. One of the things they said that they found real helpful is the steps, how to lay it out step by step by step, so you're not really wasting a lot of time, or you're wasting less. Okay, now to sight it, make sure I haven't put a twist in it. Now, once I've got that, and I'll make sure when I put the little, I'm going to put that little reinforcing web in here. When I do that, I'll make sure I drip some glue down in there and get the bottom seam on the trailing edge. So this will only be for the top seam. I guess what intrigues me about all of this stuff is there's a lot of good ways to build a wing, and there are a lot of choices. Now I know that's tacked in position. Now I can run a seam. I said before, we're making some slight changes to the flap area, wing area relationship because I anticipate this model coming out just a little bit heavier because of a little bit heavier hardware package. Next part will be just do the other part off camera, and then we'll come back to this. Now the last thing I want to do here, well, maybe not the last thing, I want to get the little webbing in front of this. The grain needs to go straight up and down because it acts like a shear web, but what it does, it locks the trailing edge into position. And I haven't taken any of the material off here or tried to do the final shaping on this because the wider I leave this material right now, it'll tend to hold this in a straight line. And all these things, they're all little detail things that help hold the wing in alignment, but in the end, when you have a wing that doesn't need a lot of trim work, or that feeling that when you pull out of a corner, it just locks right in. So much of that, I think, is just having the wing perfectly straight. So what I want to do, I want to cut the wood, grain going straight up and down, And notice that I've just left just enough room to get it in there without having, now it doesn't have to come even with the end, it can be back in a 1/16 of an inch, but it creates a box in this area, the trailing edge, that tends to act like a very sturdy, very strong box, anti-twisting box. Then everything is the last thing tonight. I want to take, and I'm thinking about how exactly I'm doing, I wanted to pre-bend the sheeting before I put it on. Now in the past I haven't done that, and that's one of the upgrades I want to make to this wing. I want to basically, and I think maybe what I'll do is I'll get that carbon fiber wing out of the attic, use that wing, because Midgley hasn't picked it up yet. Since it's basically the same airfoil, I can use that to pre-put the curve in the sheeting, in other words, to mold the sheeting. Now the other choice we would have is we could create a dedicated mold for this wing. Well, you don't really have to. For this, I think it'll be fine if what we do is I'm just going to use, actually, we could take a set of ribs and just make just the leading edge part. You only need one, and you could make one shell. The thing I'm trying to accomplish is to get rid of the stress that's in the wood. Now, a lot of times when you glue the front edge down, and you pull it down, and you pin it and hold it and squeeze it and press on it, it's putting stress. There's stress that relieves itself in time. I think by having these pre-stressed, it'll be a nice little upgrade for the wing. But before I do that, I want to get these pieces in the trailing edge one by one. They're all basically just going to be the same height, and they don't have to be ultra accurate, because if they're not tight I can push them in, but I don't want to push them in so much that I put a stress or a bow in the sheeting. So I can strip off pieces that'll be about just under an inch. Now the nice thing here is I want to get the grain going in the same direction. Can make these pieces just a little bit on the large size. And then once I have enough of them, I can just drop one down in between each rib, in between each bay, trim it to the length, and they should all be the same. It's nice is if you can make every part just the thickness of a pen line oversized, because what I want to do is leave the dust on. I want to leave the dust on. The dust helps fill the gaps and kick off the CA. You press it in just a little bit. Now, of course, with one done, I'm just going to go right down the whole wing, then make a special long one for the center. So I've got a box. The whole trailing edge is a box before I even attempt to put the front sheeting on. Now with that trailing edge locked in, I've finalized the glue seam on all of those parts. Finalize the glue seam on all of these, put an extra little drop of glue on every little joint. So this kind of locks it in now in one position. Still haven't shaped the trailing edge, that's still left to do. But I want to work on some way, again, I'm trying to build a wing where there's no pre-stress in the wood, where the wood is all shaped before it's put in position. So what I'm going to do, again, I've been thinking about this as I finish this trailing edge. I'm going to try to get that carbon fiber ring down and just use it as a plug. I need to make 2 left sheets, 2 right sheets. First thing I can do is just roughly rough out the size of the sheeting that I'm going to need to do this. I disregarded the 4 or 5 lighter pieces of wood that were lighter in favor of these that seem to have a real nice straight A grain in them. What I want to do is make a pattern up. Leave it a little bit oversized, of course. In fact, we'll leave it quite a bit oversized. In fact, we don't even have to trim that part of it right now. We can just leave this oversized. I can get this piece to come in here. I'm going to try to line this up in such a way. I have the sheeting all cut, and I need to make 2 lefts and 2 rights, of course. I'm going to soak the sheeting ahead of time. I'm going to try to just use this as my mold for the time being. Again, because Dave has not had time to be down here, but the body is, for this plane, is well under construction, and we're going to be doing the assembly down here. In the meantime, there's no reason I can't use it. Now, supposing you didn't have one of these, well, you could get a piece of styrofoam. You could have John Duncan cut. In this case, it's similar to a Miss Ashley wing, which will now be a Miss Ashley Typhoon wing. You could have him cut the airfoil, and you could make your own buck. You could probably, if you really wanted to be cute, put some fiberglass on top of it or something. But I think even just a piece of a foam wing without sheeting would be fine. Also have, and this is a wing from a model that Frank McMillan donated to our cause, we'll certainly be able to use this wing because these airfoils, believe me, these airfoils are all so close. A little bit isn't going to matter at all. So we have a lot of choices, and I'm just going to see which is going to be the most practical for laying this up. I have 2 of these wings. I have a wing. Actually, we could take what is now Don Dixon's Cardinal. We could use that because you don't hurt the wing when you do this. And you don't need a lot of pressure. The slightest amount of pressure will be fine. Just thinking of other things that would be certainly a usable choice since we don't need the leading edge. A foam wing without the core, we can shove the core piece in there so it's a little more solid. But we do have, there's a lot of ways of getting that sheeting pre-molded.
Now, what we're going to do, what I'm going to try to do, since we've never done this before, I need to come up with a little, I'm always coming up with something that I think is an invention. I'm going to do 2, instead of wrapping 1 on each side, what I thought I could do is put 1 right on top of the other. Since we're using the same curve, and it's not an exact curve, we just want to pre-curve the wood. And by the way, the phone is ringing. Whoa, okay, let me get the phone. To do, and this is really more of a test. I'm going to let this sit overnight, of course. I just wrapped it with some of the old Ace bandages. I guess that's one advantage of that most of these planes, and I would not say all, I think Billy Werwidge and Frank McMillan's planes tend to have a thinner airfoil, but all of the big planes, the airfoil is so similar that, in my estimation, it should be called the same airfoil. You'll line them all up, and that's an advantage. Because what that means is it works for everybody. And if everybody had to have some unique, crazy thing, square or diamond shaped or something, it wouldn't be an advantage. Alright, now I'm going to do the usual thing I do, is just squeeze this down just a little bit. I have 2, see if you can see this, 2 on each side, and see if it'll pick up some of that airfoil shape. We don't need it to be perfect. This just needs to be, to get the stress out of the wood. Get the stress out of the bird. Anyway, it's a good thing Midgley didn't pick up this wing. This seemed to be, when I tried the foam wing, it was like, yeah, it was kind of, when you tighten the bandages, it was just, well, but Frank's wing, I could have just cut the flap off and used that probably. Another thought, hey, just a good thought. I'm always trying to think of stuff like this. I'll put that up there later. Good thought. Somebody crashes a plane and one of the wing panels, doesn't matter, Cardinal, SV11, or Impact, whatever. Save one of the foam wing panels as a buck to make your own sheeting and just keep it in stock. In fact, you could cut the front off, glue it to a 1-inch block, and then you could, you don't have, the thing you wouldn't have to have, I had 4 Ace bandages to wrap it around that wing.
You know, what I'm going to do is hang this up by a heating vent. Tomorrow when we come back down to the shop to work, those shells should be, have some amount of the wood stressed in there, taken out of it. And I remember many times people would try to use C grain on one piece and on the bottom A grain, and boy, when you dope the wing, of course, the cells reset, and that wing would just start going, and by the time you got to fly the plane, it was as crooked, you needed this giant flap tweak. So this may be one of the upgrades that's really going to pay off in the long run. Maybe if it never works real good, we'll write about it in Stunt News. Anytime you do a shell and you can have a heating vent going, or I guess if you live in California, you can put it out in the sun. We're in the middle of the coldest part of the winter here, and that heat is going constantly, so by tomorrow, those shells will be perfectly dry. You could also put a little ammonia on it if you had some pretty tough wood. That was some pretty nice straight A-grain wood. So I hope that's going to make some nice leading edges tomorrow when we get back down here. Now, every time something like this happens, it just makes me crazy. It's happened to me many times. It's happened to, in this case, Mike Rogers. It's always the failure of the lead-out wire at the bell crank. It fails either very early on or later on, and either way, it's no fun at all. Another plane that was lost, actually lost twice because of lead-out failure. Just makes me crazy. It's the kind of thing that has plagued and haunted me for a long time. Strega was another model that, because of lead-out failure, the list goes on, and in my case, the only solution I've ever found that I was real comfortable with is the forked end bell cranks, and I've, so far, knock on wood, had relatively good luck. Now, I used to think, and this was many years ago, that this was the ultimate answer. I used to think I'd have to answer the phone, and I do. But the point is, no matter how you make these bends, you have an angle in here. And this is always under tension, relaxing. I call that oil canning. It's not a real good word. You can make this better by making this longer. You get the reduced angle. If you couldn't possibly make this, I've done it, it's almost 12 inches until it hits the joint. Solid wire is always prone to that oil canning thing. Now, the reason I liked solids for all the years is I'd see braided lead-outs fail constantly. Solids seemed a little more reliable. Well, that's not true anymore. Now, a typical way that most, including Mike Rogers, who just lost his plane, they put the wire, and it's usually 035, 038 wire. They run it through a brass tube, down through the bell crank, and what they're expecting is for the brass and Delrin to be a good bearing surface, and it's really not. They're both soft materials. Understand anything about engineering, a good bearing is when you have a very hard material and a very soft material. Brass and steel make a good bearing. But when you have a soft material like a nylon or a Delrin or a bell crank, and a brass, or even worse, if you put a brass eyelet in here and it's brass to brass is no bearing at all. Then you have the other problem that I've seen over and over and over and over, and just countless people losing planes, right here, is they'll solder the lead out. They solder the flexible cable, and right where the solder ends, it breaks right there every time, because you've detempered the metal and made a tremendous stress riser. The vibration of the plane, eventually from this wire going like that in the wing, right here is where it breaks almost every time. And one of the reasons a forked end bell crank works so well, because you have a hardened steel Allen bolt and a brass eyelet around which the cable is drawn. So you have a brass to steel bearing, which is the same as in the motor of a car, for crying out loud. It's probably one of the best bearing materials in the world. Infinite lifespan. You'll never break the bolt. You'll never break the bell crank, by the way. That's the other thing. When you make a bell crank, and I've made carbon fiber bell cranks that are a couple of grams lighter. To get them a couple of grams lighter, you need to make them out of a material that isn't a bearing material. And then you wind up pressing in all these brass bushings and praying and hoping that they don't come loose. Well, there's a way around it. When I mold the bell cranks, I mold them from 44% glass-filled nylon, which is a bearing material in itself. So there's no brass little things squished in and crushed, and we're getting ready to fly out. Crimps. We're all afraid of crimps because we all know if you crimp lines, you buy a set of lines from somebody and they sell you those little crimps that come in a package. You do that, there's a good chance they're going to fail. they fail right at the end of the crimp because you have a stress riser there from vibration. That little part is doing this constantly. But these are aircraft quality crimps. If you were to look inside of them, you'd see that inside they look, if you look under a magnifying glass, they have a radius on both sides where they do the crimping. And by the way, the ones that I use, these are aircraft quality crimps. They're done with a crimping tool. We've never had one fail ever, and I've had some pretty exciting flights, pretty long flying seasons too. So far we have 100% never had one break. But I think this is obviously the way we're going to go on all future planes until we figure some way of improving this. But I think this is pretty much the way of the future. The other thing you can do with this is you can use solid lead outs and wrap the end, but see, the wire isn't kinking. There's no oil canning. The wire is a straight run, and you have the pull on the middle of the bell crank. You're not twisting the bell crank constantly. So there's some really good engineering there. Now remember, this material is a bearing material, so there's never a time that that's going to have any kind of binding in it. Even if it were to run out of lubricant, that's a lifetime lubricant built in there. The other thing is I have 440 shoulder bolts, so that when this bolt runs down through here, the shoulder, no threads actually show, it's just the shoulder that shows, and special aircraft locking nuts that lock those bolts in place. But before I put the lead outs on, and I make these usually in production runs, I'll make about 100, 150 at a time. Never had a failure. The first thing, this bell crank, you can take about 4 or 5 grams of material out in about a minute if you're very weight conscious. Now, you can leave the edge, and I don't even suggest that this is really worth doing unless you have a super competition stunt ship. Just for an average stunt flyer, this is perfectly okay. But I can get a Dremel tool in here, just take some of this material out, and get the bell crank down to where it's the same weight as a carbon fiber bell crank, but I don't have to deal with all the little pressed in bushings and things loosening up in time. I'm much in favor of these bell cranks, even in the carbon fiber ones that I made, which I was never really happy with. I just wanted to show just how much material I can reasonably get over. You don't want to go any further back in here because that's where it makes the forked end. You don't want to go dress and leave a little extra material there. If you decide to do this, you definitely, if you want to be fanatical, and of course we are fanatical, and that'll get you another maybe 3 or 4 grams of weight off. This is what the crimped ends look like with the cable. Again, done with a crimping tool, and we test each one in a vise, of course, to make sure we have a good solid crimp. And the bolts that we use, we get from Micro Fasteners. These are special little lock nuts. And when I assemble these, I always put an additional drop of Loctite on just for insurance within insurance. These are an aircraft quality bolt. You can see the little shoulder in the bolt, and that's where the bearing surface is, the bearing that rides. Once both of the bolts are on, I have the clearance set, and of course that's set so there's no friction in there at all. I trim the excess of the bolt off with a parting wheel is the next step, and while I have the parting wheel, I want to roughen up this shaft so that the bonding agent, the epoxy, is going to get a better bite on this. Never want to leave this smooth. Important point always to get those serrations on. A small thing you can do is grind some of the head of the Allen bolt away. That gives you a little more clearance for the push rod also. We really don't need it, but it's just weight going along for the ride. Well, the last thing I'll get to do today, this will be I got to drill a hole for the push rod, 093, exactly 093. Drill a hole in here, 093, and make up my arrow shaft. Now I remember somebody who made an arrow shaft up and just glued the wire in here, never put the spur coming out the arrow shaft. That's the single most important thing on the whole arrow shaft. Right, Bruce?
Great tip from an expert. Never hold this by your bare hands and try to drill these holes out. This thing is like a razor blade. Not that I've ever done that. I can't even do it with pliers. Oh, this is a snippy one. You want to have, of course, a tight fit on the wire. You don't want to have the wire slobbering around in there. Now the other part, need to drill this out also. Need to know just how far back to put my little spur. I want to trim just enough of this wire off. Just enough so a little bit of it sticks out of the arrow shaft.
Well, this is the key, and I'm not kidding about that. That little piece, when you slide this in, that should be a tight fit. This should stick up some. Now I can CA this whole piece, and then I'm going to wrap this with some extra carbon fiber. I have seen these break in service, right, and they usually crack right at the end here, so I always wrap this end with carbon fiber. And once that end is wrapped with a little bit of tow, a couple shots of thin CA, and this may be overkill, I don't know. Now sand this down and dress it off with some thin CA. I really want that to be as solid as could be. I don't want 15, 20 years from now that, oh, there goes the Typhoon. Maybe some steps you can leave out, but when I use that word bulletproof, bulletproof means it absolutely, positively isn't going to wind up shooting you. This is just to dress it off for my own little rated. I've done this for years. It seems to work. Never seen one fail yet that's done this way. Have seen them fail when they're not done this way. I think you can figure out the rest, because I'm building these planes and I'd like to know that they're going to withstand that inevitable test of time. Now I try to set this angle before I solder on the keeper. This is too much of an angle now. And one thing you never want to do, this is a big mistake. Some people put the push rod up high. The higher the push rod is, the more torsion there is. You'd like to get it down as close as possible. But I can see I need a little more bend in the wire. The problem is, I never want to bend it all the way and then back, all the way and then back. I want to bend it just enough. And if I have to bend it back, I'll go replace the wire. That looks like just what we need right now. See, what I've done is a way to hold a washer while I'm soldering it. It's Stay Bright, and of course all the soldering is Stay Bright. Just press it into some end grain balsa. Set the clearance. You could set the clearance any way you want. In this case we want it down almost flush, not quite, and get the clearance real accurate. And what this does, it holds it at dead 90 degrees. You don't have the washer one way or another while you do the soldering job. There's never a time I would recommend any kind of solder except Stay-Bright silver solder. And I am not the world's greatest solderer. And boy, it makes you a good solderer though. Now what I do is I always put a little, I'll call it a safety, the little notches for the copper wire, put the eyelet in place. I don't want to solder right up on the bell crank. The eyelet lets me solder a little bit further down the road. And what I do is I take this, give this a couple of wraps with the soft wire, and even if the solder joint at some point in time deteriorates, the copper should be a backup redundant system. The most important part of any job, getting the defluxing agent, which is baking soda and water. Plenty of baking soda and water to neutralize the acid on all the joints. And we're pretty much ready to install this little guy. He's ready. Next time we work on the wing, we'll have the control system. We need to do the leading edges. We'll at least be a little bit ahead having this part of it done. Now today, this is a significant thing. This is one of the significant things you can pick up off the tape. You see what I do is, I'm going to be working on the wing leading edge sheeting today. And one of the things I have is the tape from the previous year. Hey, this one's already got the sheeting on it. But by reviewing a tape before I actually do the work, and I can do this while I'm doing the business part of this regime, by having a video library, I can look at it and I say, oh, Jeff, almost forgot that step, almost forgot this, almost forgot this. I get a good idea, and it was really important last year, or a couple of years ago, when I was painting the roundels. I had forgotten how I backmasked the roundels. So having a permanent video library, to me, is a really, really important thing. Now, because we're improvising, I wanted to see how I did this last year, and then I want to see if I've made any improvements. Now, I'm going to go pull the sheets off. They've been up by the heating vent, and see if they're going to be usable for this application. But again, even if they're not, what's the worst that can happen? We go back to last year's system. But having that ongoing video library, and especially things like the Miss Ashley tail, which we're going to use over and over again, building D-tube wings, we do it over and over again. Anything you're going to do repetitively, paint jobs, backmasking, inking, having a video library is a key thing. Very helpful to me. I guess the part of it that I'm not telling you is I forget everything. I go to the store for milk and come home with buttered rolls sometimes. Now, of course, I have two together, but look at the curve. The airfoil's already in the piece of wood, and I did two joined together. I have to just be careful when I pull them apart here. There we go. So what I did, and again, I think this is an upgrade over last year. I have the airfoil roughly in there, and it doesn't have to be super accurate, but I've got pretty much all the stress out of the wood. Now what happens, let me show this. A lot of people don't understand. When a D-tube wing, once the dope starts to shrink down over the leading edge, and you can see it, it puts stress into the wood. Every time you wet the dope and let it dry, wet it, let it, and it's constantly shrinking and taking its shape back. And at some point in time, it stops. And in this case, this is what we're trying to replicate. This wing, I thought was the best compromise of all the aspect ratios, all the flap thickness, all the things that I thought were the best of all the planes. This was my favorite. And what I'm trying to do is just make it even a little bit better. Now, a lot of people say, oh yeah, when you get to a certain point, you should just keep building the same plane over and over again. Well, I would, except it's boring. It's probably better from a competitive point of view, but it's just boring. So now I'm going to see, we're going to try laying some of these in place here. They have to be trimmed, of course, but that'll already, just look how nice that's going to be. I hope that's a little upgrade everybody can use. And you can use one of those crashed planes to do it. That's just a great idea. The curve really did work out perfectly. Oh, I wish I would have thought of this. Why didn't I think of this years ago and patent it? Now what I can do here, I want to trim this edge. With a real easy way to do it, I just lay a piece of masking tape in parallel to this, and that gives me one edge of this. Tape establishes my parallel line for this joint. And I can just take a brand new blade and slice that off. And once you get rid of that piece, that allows you to get that edge exactly right in one cut. Now with this piece, I'm just working off this edge. This edge is hanging over just a little bit, just because I don't have Mike here or anybody to help me. Just a couple pieces of tape hold it in place. I'll do the same thing with a piece of tape. I know what the center of the ring is. A piece of tape gives me a nice edge. See, you just can't do it with a ruler because this really is a curved section. It's better to do it with a piece of tape. Set that edge. That's just for my own reference. I like to get that line exactly on center and exactly 90 degrees because then I can use that joint for lining up the wing. So I've carefully measured it out. Put the tape on and remember, you just can't, it's hard to imagine this. This is not a straight line. When you go around a curve, it tends to have a little bit of a curve in it. So I want to check that that's right, and I can just trim that piece. That gives me the two critical joints on the first piece of sheeting. Thing is to calculate out. See, the thing you want, this is going to be the little brace, the spare brace. To calculate out, you don't want to have the pin of the belt crank pivot on the center. You want it half of the distance. This is 13/16, so we want it 13/32 off center, so that at the middle of the throw, this push rod is right in the middle of its travel. It's in the middle of the fuselage. Now to do that, this needs to be offset half of that amount. I'll calculate that out off center, and then that'll be one of the pieces, and we're not going to put the belt crank in there, but I want to make enough room on this that it'll fit, and that little point will be just enough off center that at mid-throw, again, my push rod will be right in the middle of the fuselage. How nice is this? We already have the curve in the wood. What I did, I just tack glued the leading edge on, but I already have the curve in there. So rather than not pulling this down, now what I'm going to do is at each rib station, I'm just going to very lightly, because I don't have to glue the ribs yet. I'm going to have the ring upside down, I'll glue the ribs. But right now what this allows me to do, I'm just going to pull this down at each rib station, get that rib secured. Go to the next one, so that I don't have a buckle in the sheeting, and I can do one at a time. But before I do that, I'm going to take some tape, just to keep this. See, I don't want to start bending a curve into it, so I'm going to tape it all down with those little pieces of tape. See, I'm always trying to figure a way of working when I'm by myself that I really don't have to have a helper. But if I have a helper, what I would do is, if you have the luxury of having somebody at your house, is kind of do this and have them just hold it in position, and you can just get it glued in. Either way.
Now again, this is another, we're getting into overkill here, but I can put a little tension on this back. That'll help. Always nice to be able to do things without a helper, but then if you have a helper, and this is a very busy time for Mike since he does snow plowing. We are in the middle of, by the way, it's a sad moment in our time here. Don Dixon was ready to come up for a visit, and if you'll see this, it'll already be over, but Arkansas had a terrible ice storm and kind of cancel his visit, so we'll be looking forward to maybe a little further into the spring getting him.
I'm just tacking it at each rib station first. Putting a little bit of backward pressure on it. And once all these tacks are dry, then I'll just run the whole glue seam. And once that's dry, get rid of the tape. I can just kind of look under here and see what kind of fit I have, and it looks real good. And now one rib at a time, I'll go down the whole rib. just one rib at a time. Just want to get some of that little carbon dust off of this, even though I don't want to sand, I'm not block sanding, that's for sure. Just want to get the carbon dust off here from making this on a carbon part. Next thing I want to do is put a little lip under here so when I do make this joint, I have a little place to join it. Now as I lay out the second sheet, this is not attached yet, I want to get this angle just right. So again, a good way to do it is just lay a piece of tape in here. Once I get this joint set right, then I can trim off the outside. Making these joints, I haven't put the little lip in there yet because I'm going to use the part that I cut off, which already has the curve in it by the way, as my little furniture joint. If I put this edge of the tape right up against the joint, it means when I cut here, I should have a really nice butt joint. Took this little piece, and of course it's already got the curve in it, and chamfered it to even further distribute the drop-off point and get rid of the stress rise. So this is going to be right in the middle of the wing. Now I need to tuck this under here so it acts as that little, I call it a furniture joint, I'm not sure what the real word is. Gives me a nice little joint, and remember, because this is a take-apart plane, this piece will lay right in there. A lot of the torque is going to be concentrated right in this middle box of the wing. We want to make sure that's as strong as it possibly can be. So that tape method, we have a really nice joint here too. Okay, so I'm going to put this outer skin on. Same way I did the first one. Glue the front, tape it back. Don't need to do that on camera, and we'll have the full leading edge sheeting on this very soon. Okay, with the sheeting on, the next step is going to be to do the center sheeting and the cap strips, but before I even go to that step, I want to get in here and make sure I still have a center line. Now it's a little difficult because I have to trim the leading edge here a little bit to do that. I have to run a blade down there, but I still want to see that I'm on center in every station that I possibly can, and just get a reference off the center line of the rib, because if I for instance in putting this on had put pressure on it, put a bow in it, whatever, I can still take it out now a lot easier. Once I flip it over, then I have to rejig it, and I won't have the benefit of having that real accurate center block. So I'll check. I'm going to take this piece off the trailing edge so I can get a reference for the center here. It's a little bit of a lip on here. I can only do one side now, but I get the lip off, then that'll give me a little better and an additional reference right across the trailing edge too. So I can get the last little bit with a sanding block. I want to take the bulk of this off. I've done this before with a plane and then taken a little bit too much off. I think this way, just want to get it down to the last little bit and do the last little bit of this with a sanding block. What you don't want to do is make a sanding block and only do this area with a sanding block, so wherever there's a rib, you make the sheeting thin. So what I try to do, get that last little bit off, but I'm trying to concentrate the weight down on the trailing edge. I don't want to thin out the sheeting anymore. You certainly wouldn't want to sand the leading edge with a sanding block now, because you'd pick up all the high spots, and right where the sheeting should be the strongest, you're going to make it the weakest. Again, right about now, I'll be making up various lengths of sanding block from our top blocks, old top blocks that are too heavy and whatever. But just to get this last little bit, before I start the center sheeting, and then the last little bit I can dress off this way. And usually when I do this, if Mike is here, I have him hold a vacuum cleaner right here, so that it gets rid of a lot of the dust for Karen's benefit, but right now I'm just trying to vacuum up a little bit as I go. And it's sanded out real nice. We're ready now to do that center sheeting. Center sheeting, I certainly don't want to use this lightweight wood. I've tried doing this many times, and you wind up having more problems than it's worth. What I do want to have, though, and I know there's a couple of pieces in here, I had some
and they were on the heavy end of this. I had some C grains. Oh, they were the real heavy ones. 15-grain sheets. Doesn't matter. What I want is this real C grain, because when I lay this out, this is going to be taking a lot of the stress of the wing, and when I sand it, I want, even if I get it down sanded a little thinner than this, I don't want this to be that wrinkles all over it. Alright, so I'm going to lay this out with a piece of C grain. It's going to be even more important when we lay out the bottom piece, because the bottom piece is going to have the fuselage sides actually transferring the torque of the engine through the wing. So the top would be the less important of the two. So I'll save the piece for the bottom. That I have one piece of real hard C grain, and that would be a great piece for the bottom. This is the second hardest piece. Now I need to just lay this out. First step, I'm going to lay this sheeting out, and I'm going to let it go out a little bit further than I normally do and leave the center reinforcement a little bit stronger, because I anticipate doing touch and goes with this plane. Normally, the only landing you'd ever make would be like a glide type of landing, and it wouldn't be a big deal. But I anticipate doing some touch and goes, and well, we'll see. We'll find out. Now, I want to get this angle as the first thing. Well, the easiest way to do that again is with the tape. Line the tape up with this edge, and then just transpose the angle right out there. Just good modeling techniques for anything, any project. Use the edge itself as your guide. Since we know we're not going to be able to do it in one piece of sheeting, it doesn't even matter. Now I can take this off, and I have the first edge. Again, I really hope I'm going to be able to do touch and goes with this. But even if I can, even just landing it with the engine running, with a 91 with a 14.5 rev up or something. Okay, that gives me that edge. This ruler I got from John Puffy has certainly turned out to be useful, and I could suggest anybody with bad eyesight like I have. Black rulers with white numbers really seem to be a lot easier to use, and I still have no idea why. You would think I would just go buy glasses or something. That's another good little tip. And actually, any little tip you can pick up off the video is a good modeling tip. I really wish somebody else had started making videos so I could be picking up more tips. Especially with that composite stuff. We're going to be back to doing that soon. Good trick for getting two sheeting joints to butt real nice, and that is to kerf, meaning instead of this being a 90 degree, make it about a 30 degree back cut. The advantage of that is now that edge is more able to push its way up and make a tight joint. And I always sand these and I leave the dust on. I get a little kerf on the edge, that little kerf, I don't even know if that's the right word. This is not an English literature course. You want to learn English literature, go to college. You want to build great models? Don't buy Windy Video. Okay. Let's see how close we have it. Relatively nice. There might be one or two little high spots because these sheets in here, this is not a true edge. We don't really need it to be a true edge. But if it's hitting on a hard spot, just like I always say doing sheetrock work, a couple of swipes, but notice that I got the block on an angle. That's one of the tricks for getting those joints real nice, no matter what kind of model you're making. Now the reason for having this piece, in other words, a lot of people do it just the way you would do a standard 35 ship. Well, but a 35 ship doesn't take the loads that a 60 ship, or in this case a 91 ship. So, but this piece of wood that joins from here to here, it's a trademark of the Cardinal and Strega series of plans, so I think Tsunami too. And it adds a tremendous amount of strength right at the high point of the wing. Right at the high point, where you need it the most. So I would suggest this is a good way, no matter what design you're doing, is get this sheeting design down here. And again, I'm leaving more material in the center for the simple reason that I'm hoping this is going to be really rigid while it's taxiing around on the ground. I take this in position, and now I can lay out my angles here. And this is a relatively straightforward thing. I put a dot in the center of the wing at whatever height I want, and the first thing is to connect the two dots, and that gives me the angle of this piece. I always leave these sheets hanging over the rib about a 1/16 of an inch. Just putting a light incline on this, and I'm connecting that same dot. Once I make one of these, of course, I'll have a pattern for the bottom to, at least a starting pattern. I also, and I think this is real important, I want to get a radius in here. I don't want to have this come to a sharp point. So I have to get that circle template and get that radius. Again, no matter what design you're building, this is good technology. Keeping this corner rounded gets rid of a stress riser in a possible place that you're going to have trouble with the silk span wrinkling or any other number of maladies. Okay, that's our rough layout now. Now we can look at it and see if we're happy with it. If we are, we'll just cut that up. It's always handy to have here is a roll of this sticky back paper. You can get nice edges if you want to make them all the same. It's ready to lay out. Now we're going to do two things. While this piece is in my hand, I'm going to make a duplicate for the bottom, and it'll probably have to have a slight adjustment or trim, but that's okay. I'll have it based out. I won't have to lay out all these angles again. And I'll also make a pattern for Elliott Scott for the final Typhoon plans. Put in the box, we're making patterns of everything. Get us a little bit ahead when we go to do the bottom, and we'll also have the pattern, because Elliott does such a good job on the plans, but I have to give him accurate templates or they're really not worth doing. And he, by the way, is building his own version of the Typhoon also. Okay, now the tape is pulled in tension, so I get a tight fit. I'll tack that joint down. Then I'll be able to lay in some tight bond on there. I don't really even have to, because once I flip it, I can glue the back. The nice thing here is I just like to tack this in place. Then when I take the tape off, I can run the seam. And see, like if the phone rings right in the middle of doing this, no problem. The piece stays in position. That's amazing how nice that tape pulls the seam shut with the little angle on it. It takes almost no sanding to get it really nice. The next thing after sanding this, we're going to join this down, because when we flip it, we can run the glue seam. I need to, using the same technology, and lay out this piece of wood back here. When I actually cut that last piece, I like to dress this off, even though the seam came out real nice. This way, if there are any high spots, any bad spots in the joint, they'll show up right now before I do the cap stripping. Yeah, nice these joints ultimately did come out. And I'll just lay this piece out here, and then I'm done with the center section sheeting. I am always reminded exactly what happens when lead outs break. This is of course Tsunami. We've had that footage on many videos already, but that's a good idea when you incorrect lead outs, and I've been as guilty of that as anybody. That's why I'm so much in favor of the new system, so that never has to happen to you. You were wondering how bulletproof these gear blocks are. If you can break the wire, I don't think you need to make them any stronger than if you break the wire. This is one of the few things that we got from this
imminent crash. By the way, this would be, thinking of things, this would be a good panel to save. Or the next time you have a crash, and I'm going to write about it in some news, save the panel for making a mold for molding your leading edges. Anyway, those are bulletproof gear, bulletproof controls. I think that technology will serve everybody well. The last step on this video, and we're coming up on the end of the tape, we're going to lay out the cap strips. Now, a couple of thoughts that I've had over the years. I've tried to use really punk wood to do cap strips. Forget it. I'm using real hard sea grain because those edges are really delicate. And what happens, whatever weight you save in using punk wood, if it's not sea grain, what happens? The edges get all rough and then you wind up filling it with silver paint that weighs much more than the original. And that'll be the last step on this side of the wing, is to get all the cap strips in.
Take off your coat.
Too, I always put the stripper on a little bit more than a 1/4 inch, maybe a 1/16 more. Just a little bit on the plus side. And boy, nothing but sea grain.
Having the cap strips all cut up ahead of time. Now I can just start at one end of the wing, work my way right down. Now the thing that the cap strips do, by putting them in while both rods are still in, it helps lock the wing into position. And what I do, I take a brand new blade. I prefer a razor blade for this operation because I want to make little back cuts on these, on each one. I try to line one end up, get the angle, and get these just a little bit oversized. See, I'm holding the razor at a back angle, a little bit of an angle. Because what I want to do, I want to dress this off, and I want this to be almost like a little bit of a press fit. See how it pretty much stays there? Now I can push the middle down, and that'll give me both joints real nice and tight. Remember, it's that little angle, just that little angle, not a 90 degree, maybe a 45, that allows this to work so well.
You don't need to be afraid no more. You picked up happiness and laid the worries out. You're gonna live easy.
And of course we're trying to get them right on the middle.
You're gonna outshine every woman in this town. And remember, when crown comes.
The trick, of course, is to get these all at the same height. So I try to get these joints. I don't want to sand it real thin to get these joints the way I want them. If the cap strip's low, just break it away and bring it up a little higher. This lets me do 2 at a time. The objective here is to avoid having any real thin spots. And of course, within the next little bit of time, I'm just going to work my way right out, right to the other end, and that'll end the cap strips. Good little tip if you have bad eyes like I do. I kind of mark each rib with a little dot. You know, when I go to put the cap strip in place, see, I avoid doing that. I can kind of line it up. It just makes it a little bit easier, but it's real important that they be a press fit.
Now, whenever I do this, I always like to check it with my finger to make sure I'm happy with that joint. Use the vacuum cleaner to just try to keep the dust down in the house, sanding it. Needless to say, it's best to go front to back, not side to side, or you tend to break cap strips.
so good to have one wing done and know there's only one to go. Anyway, it seems like the second one always goes faster than the first one for whatever the reason is. Well, we finally got the cap strips done, thank God. We are closing in on having a wing. And it's every time I work on a plane, it always gets to some point and it starts to become an aeroplane. And I think we're well on our way to having that right now with the Typhoon. The carbon wing turned out better than I ever could expect for our first test panel. The carbon flaps, again, we even wound up using it for a plug for molding leading edges. It was sad to miss Don Dixon's visit, but I know he's iced in Arkansas, and his wife's recovering from a back operation. So Don, we'll look forward to seeing you in the spring. Basically ready to lay up our next fuselage. Mike's ready to work on his plane next week, as soon as this New Year's thing gets over with. Well, I look at our project room. We've converted one room of the house into a combination kit production room and storage room for our future projects. And boy, if I ever could have looked into the future, that day in the diner, Joe Adamusco proposed building Spitfires, where it was going to lead me. Sometimes I just wonder if it could ever be better than this. And no matter where this Typhoon project takes me, the Spitfire project will always be right behind it. And we've reserved a whole wall in our Spitfire bedroom. This is soon to be dedicated to being the Typhoon part of the room. It'll soon become the Typhoon Seafire Spitfire bedroom. And as soon as the weather breaks, we're going to get out and test our Zetron, test our 91 Sato, test that laser. I just don't know if it could ever get any better than this. And I still, in the back of my mind, I still have some hope that I'll be able to get this YS to run a little better. That's why I haven't taken it out of the plane. I'm just